In this lesson, we are going to cover what you can expect to learn by viewing the Infinite Skills Introduction to Learning SolidWorks 2014 lessons. Before we discuss the topics we will be covering, we are going to go over some basic terminology used in SolidWorks and the design industry in general. First, SolidWorks is a parasolid-based solid modeler and utilizes a parametric feature-based approach to create parts and assemblies. Now, what do I mean by parametric feature-based approach? The key word is parametric, or parameters. Parameters refer to the constraints whose values determine the shape or geometry of the part or assembly. Parameters can either be numeric parameters, such as a length of a line, or a diameter of a circle, or geometric parameters, such as tangent, parallel, concentric, horizontal, or vertical. Numeric parameters can be associated with each other through the use of relations, which allows them to capture design intent. So now, what is design intent? Design intent is how the designer of the part wants the part to respond to changes and updates. For example, let's say you want the hole at the top of a soda can to stay on the top surface, regardless of the height or size of the can. SolidWorks allows the designer to specify that the hole is a feature on that top surface, and will then maintain the design intent no matter the size or height of the can. Let's begin talking about what we are going to cover in these lessons. Building a model in SolidWorks usually starts with a 2D sketch, although 3D sketches are available for power users. The sketch consists of geometry such as points, lines, and arcs. As you create the sketch, geometric relations are automatically added to the sketch, such as tangency, parallelism, perpendicularity, and concentricity. If needed, you can also add geometric relations manually. After the geometric relations are added, dimensions are then inserted into the sketch to define the size and location of the geometry. The dimensions in the sketch can be controlled independently or by relationships to other parameters inside or outside of the sketch. The parametric nature of SolidWorks means that the dimensions and relations drive the geometry, not the other way around. In the sketch lessons, we will cover many, if not most, sketch tools, from lines, circles, arcs, all the way through sketch patterns and repairing problem sketches. We will also cover good sound sketching practices to follow as you build your sketches. So when you complete the lessons for basic and intermediate sketching, you will have a good foundation to build from. The next major area we will cover is part creation through the use of 3D features. After the sketch is completed, we then utilize the appropriate feature to give us the desired results. Features are the building blocks of the part. They are the shapes and operations that construct the part. Features typically begin with a 2D or 3D sketch of shapes such as bosses, holes, and slots. This shape is then extruded or cut to add or remove material from the part. Some features like fillets, chamfers, and shells do not require a sketch and can be applied directly to an existing feature. In the Infinite Skills video, we will cover basic feature commands all the way through intermediate features. We also have many lessons testing your newly acquired skills. After we conclude the discussion on features and part creation, we will move on to assemblies. In an assembly, we apply the similar relations that we apply when we create sketches. However, we call these relations mates. Just as sketch relations define conditions such as tangency, parallelism, and concentricity with respect to sketch geometry, assembly mates define equivalent relations with respect to the individual parts or components, allowing the easy construction of assemblies. In the assembly lessons, we will cover all of the standard mates along with a few intermediate assembly techniques. We will conclude this training with 2 chapters, more than 20 lessons on how to create 2D drawings. Drawings can be created either from parts or assemblies. We will cover the necessary techniques to generate views, notes, dimensions, and tolerances from the part and assembly models. We will also examine how to create bill of materials and custom drawing templates.